First, let's quickly talk about what frequency histograms are. And basically, these are tables that tell us how many values there are. So, for instance, for numbers between 20 and 29, I'll explain why I said that number in a moment, but there are 3 of these numbers. Now, we don't know exactly what the numbers are. We don't know if they're 20s or 29s, but we know there are 3 of them. And going on, we have 4 numbers in this area, 7 here and 9 here, and we have 3, 4, 7, and 9 numbers here. Now, in this question, we're being told that each interval represents the frequency of the integers that are greater than or equal to the number on the left, but less than the number on the right. So just explaining what that means. These numbers, well, they're all integers, so there are only 10 real numbers from 20 to 30. But they can be 20 and they cannot be 30 because they're greater than or equal to the number on the left, but less than the number on the right. So same thing here. That's what the green part says, greater than or equal to 10, but less than 20. And for the next bar, greater than or equal to 20, but less than 30, and so on. So the question is going to ask us, what's the smallest possible difference between the means of the 2 sets of data? The thing to notice is that set A goes from 20 to 60 roughly, and set B goes from 10 to 50 roughly. So if we imagine these 2 averages on a number line, set A is the greater average, and set B is the smaller average. So if we want the smallest possible difference between those means, between those averages, that means we want to kind of figure out how to make B as big as possible and A as small as possible, so that the difference between them, the distance, will be as small as possible. So let's start by trying to make A as small as possible. Well, because we don't know exactly what numbers are in here, they can be any integers from 20 to 29, but they can't be 30 like we said earlier. So if I want this set to be as small as possible for set A, I'm going to imagine that we have 3 numbers that are 20, and for the next bar, 4 numbers that are 30, and 7 numbers that are 40, and 9 numbers that are 50. And we're already told that each set has 23 integers in it. Now, doing the math on that, multiplying, adding, and then dividing, we'll get 39.56. Now let's do the same thing for set B. Now remember, the numbers in the first bar for B, they can be 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, but they can't be 20. So if we want set B to be as big as possible, then we're going to want that 19 for the first bar. So we have 3 that are 19, and for the next bar, 4 that are 29, and we're just going to do the same thing for each bar. 7 that are 39, and 9 that are 49. And once again, we're dividing by 23, and when you throw that all into your calculator, you'll get 38.56. So we did the math and we figured out that these 2 numbers here are exactly 1 apart from one another. Maybe without doing the math, you can kind of see that we kind of have all the same numbers, except these are all 1 greater than their counterparts in the other group. So either way, the sets have averages that are exactly 1 apart. And that's the reason why the answer here is B.